All right, number 4. Which table contains only values that satisfy the equation y is equal to a half x plus 14? Okay, this equation is our linear equation, which is on our handy dandy reference material, which is y is equal to mx plus b. Okay, so y is equal to mx plus b. That m is our rate of change. That's our rate of change, and that b is our y-intercept. Okay, so where my line crosses the y-axis, my x is 0. Okay, so for that y-intercept, that number is where x is 0. Okay, so when I look at my tables here, I have 0 and 0, which can't be right because I need this to say 0 and 14. So A cannot be right. C says 0 and 14, that's the y-intercept. B also says it, that's the y-intercept. D also says it. So those all say the correct y-intercept. All right? So what this equation here means is that whatever value I say for x, when I plug it in, it's going to give me the value of y. So my next number is a 5. So what I'm saying here is that if I multiply a half times 5 and I add 14, it will give me the y value that I need. Well, 5 times 5 is 25, and I put my decimal in, I would get 2.5, which you can multiply that out if you need to. Add the 14, so that's 14 plus 2.5 is 16.5. So what this means is when x is 5, my y value is 16.5, which is what C says. B does not say that, so B is gone. And D does not say that, so D is gone. Okay, it's always a good idea to try to have 3 numbers to match. So if I do this again and I use 10 for x, all right, 5 times 10 is 50, but when I put my decimal in, it's going to give me 5. And 5 plus 14 is 19. So when my x is 10, my y is 19, which is what C says. So I'm very confident in my answer choice C. All right, number 5. Mildred has a bag of coins. The bag contains 10 dimes, 5 nickels, and 1 penny. She will randomly select 2 coins from the bag one at a time without replacement. So she is not putting it back in there. What is the probability that Mildred will select a dime first and then a penny? So this is probability. With probability, every action gets a fraction. Every action gets a fraction. So I want to know the probability of her first selecting a dime and then a penny. Every action gets a fraction. So I'm going to have a fraction for the dime and a fraction for the penny, and then I will multiply that together. So I have to find out the total number of coins I have. So I have 10 dimes plus 5 nickels is 15, plus 1 is 16. So I start off with 16 coins. Okay, I want to know the probability of drawing a dime out. There's 10 dimes. So this is going to be 10 out of 16. All right, this is without replacement. So she does not put the dime back in. So I no longer have 16 coins. I have 1 less. So I now have 15 coins because we didn't put the dime back in. Okay, she drew the dime and kept it. So now I have 15 coins, and I want to know about drawing a penny, and there's 1 penny. So that's 1 out of 15. So the action of drawing a dime is 10 out of 16. The action of drawing a penny is 1 out of 15. And now I'm going to multiply. So 10 times 1 is 10, and 16 times 15, let's see what that is. That's 240. Okay, so when I multiply, I get 10 out of 240, which is not an answer choice, but I have zeros on the top and the bottom of my fraction, so I can just quickly divide by 10, and that leaves me with 1/24, which is answer choice D. So the probability of drawing a dime, not putting it back, and then drawing a penny is 1 out of 24. All right, number 6. Anna drew a map of the Panama Canal. In the scale Anna used for the map, 4 centimeters represent 20 kilometers. The actual length of the Panama Canal is 82 kilometers. What is the length in centimeters of the Panama Canal in Anna's map? Okay, this is a scale drawing. We have 2 different units here, so we're going to need to set up a proportion. Okay, and you're going to need to label your proportion. We're using centimeters and kilometers, so you always want to label it so you make sure you get your numbers in the correct spot. So our scale is 4 to 20, so 4 centimeters. Centimeters is going to go on top, kilometers is going to go on bottom with 20. The other number they give me is this 82. It's a kilometer, so it's going to go on the bottom with the kilometers. 82. I want to know the centimeters. That's my x. And then I just solve my proportion. So 20 times x is equal to 4 times 82. And 82 times 4 is 328. So 20x is equal to 328. Divide both sides by 20 because that's how I solve. So I want to know how many times 20 can go into 328. So 328 divided by 20. 20 can go into 32 one time. Subtract. Bring down your 8. 20 can go into 128 probably about 6 times. Using our answer choices, it's going to be 6 or 5. So 20 times 6 is 120. So subtract. I've still got a remainder, so I need to add a decimal, bring that decimal up, add a 0, bring that 0 down. 20 can go into 80 4 times, nice and even, so I'm done. So what is the length in centimeters of the Panama Canal on Anna's map? It's 16 4/10. 16 4/10. Right there, see? Nice and easy.